Jeremiah Lowin, CEO and co-founder at Prefect. Welcome to the Data Exchange Podcast.
And thank you for having me. Thank you.
And all right, so let's start. I just was on your website. I grabbed the tagline: the easiest way to build, run, and monitor data pipelines at scale, which for our audience who follow data engineering closely, this is an incredibly exciting area. Data integration, data pipelines, data quality, all the surrounding things. And yet you guys have settled on a specific aspect of it, which is orchestration. So what of all the things you could start a company on and project, Jeremiah, so why orchestration?
Yeah, so I think if you refresh, or if you look at a moment, you'll see that tagline change. Actually, it's going to say orchestrate happiness. And one of the reasons that we focused on this is because it's probably the most hated point in the stack, number one. And number two, because very few people set out to deal with this problem. This is a problem that you learn that you have. This is a problem that you learn because tool A sends data to tool B, and somewhere in the middle it gets lost, or somewhere in the middle a node crashes. And so the entire problem of orchestration itself is an ugly word. It's a difficult word. Most people, you say orchestration, they're not even sure what you mean. And so when instead we talk about the movement of data, automating the movement of data, or more precisely, monitoring and keeping an eye on and giving you confidence about the movement of data, sometimes the light bulb starts to go off for folks and they say, you know what, I hate dealing with that. I deal with this all the time, but I hate dealing with this. I'd much rather just work with the tools I have, sort of get my production systems running, get my analytics in place, and not have to worry about, I schedule this for 9 a.m. Does that account for daylight savings time? I don't know. I forgot to define a field in my schema. When the data comes in and has that field, is it going to crash? A null came into my database. Is it going to be supported? All of these edge cases come to consume our worries, as data professionals, and we all hate it. We all hate it. I've hated it my whole career. And I think that's the entire opportunity, is if we can actually put ourselves in a position where we can turn that into an exciting project, one that we as a team, as a Prefect team, get excited about, then there's actually this extraordinary opportunity to deliver value to people because we can work on it, something we enjoy. And universally, people do not like this problem. I think that's a beautiful, beautiful opportunity for a business. So that's a simple answer. I mean, there's more technical things that I'm sure we'll dive into, but at the heart of it, it's an ugly problem. It's a problem people don't really want to deal with. And it happens, it gets us really excited because it puts us at the center of a lot of really exciting use cases.
And it's also such a fundamental need that you must address in order for you to do anything interesting, be it reports, analytics, machine learning, right?
Absolutely.
So then if you look back 10 years ago, maybe the minimum viable entry here would be cron, right? So in terms of the modern expectation of a modern data team for an orchestrator, so what are some of the key things they're looking for? I guess monitoring, scheduling. What else?
Yeah. There's a couple basic primitives, and actually the way we refer to that in turn, we call that fancy cron. Because at the end of the day, you are 100% right. It's cron plus a UI, plus it's easier to write, plus better tooling, better developer experience. But at the end of the day, it's fundamentally a paradigm that has existed for not just 10 years, but quite a few decades now. So you mentioned scheduling, monitoring of any kind, just reporting on state, logging, error trapping, retrying, we think is the number one table stakes. It's retrying is probably the thing that people think is easiest. And I think it's probably actually the single hardest technical challenge we've come across. Because being able to make guarantees around it is hard. All of these things are these primitives for how work is done. And I think that's the broad characterization. How is work done? Where is work done? Very different set of questions than what work are you doing? So we have users who are training a neural net, and then we have users who are just moving a couple bytes from A to B. And both of them may choose to partake of different orchestration primitives in different ways. Maybe scheduling is important, maybe reporting is important, maybe retrying on error is important. The most difficult thing for us to do as a software team is to deliver those orchestration primitives, those sort of I don't know, meta computation primitives, like separate from whatever the principal objective of the code is. I think that is the place where we spend most of our time. Is how do we give people a way to take advantage of these ideas and these tools and these primitives without inviting them to rewrite all of their code? Now that's the sort of what we call the fancy cron world. That's what features can we deliver so that someone can just add this to their code, take advantage of these things that, yeah, could have done it in the past. That's very different than where we deliver value to our users. I actually think we can make a strong argument that's very commoditized, what I just described. And you can find hundreds of tools, right? That probably
That's why I kind of describe it as like minimum viable things. Right?
Exactly right. And like there's a whole lot of these basically minimally viable orchestrators in the world because they focus on this. I've built many myself over my career because at different times in my career, all I wanted are something that will schedule something at 9 a.m. I don't really care past that. But where we deliver value and where we can actually build an enterprise product has almost nothing to do with those fancy cron features. We deliver value because of where those features help people. And it's very interesting. It's not when things go right, it's when things go wrong. And so I think the cron, if you think about using cron and a whole bunch of scripts, if you could guarantee that everything was going to run the way you expected it to, we probably wouldn't move much past that. We would literally have a fancy cron with a UI, and that would be that. It's precisely because there's a probability that something will go wrong and that you need to be able to go in, debug, introspect, and fix it, that there's actually value in collecting a very rich set of information about what it was that you're trying to do. Because we can now deliver a far superior experience in that failure case, in that edge case. And so that framing is really important for my team, because the way we think of that is if our opportunity to deliver value increases with the probability of something going wrong, then what we've actually built is an insurance product, because that is how insurance works.
And by the way, the probability of something going wrong is 1.
It's 1. At somewhere in the infrastructure, it's 1. But you know this. I don't have to tell you this. Good luck trying to convince somebody of that, right? Right. Not only is the probability 1, but the probability is probably 1. In all honesty, it's probably no one person's fault, right? It's probably some random, who knows what, internet hiccup. But the probability is definitely 1, conditional on it being somewhere in your infrastructure. And so being prepared for that, it becomes a cost benefit thing, right? Just like any insurance. And in the very early days of Prefect, we used to really use this mental model. You don't buy insurance on your house because every now and then you come home and it's on fire. You buy insurance on your house because if it were on fire, the cost would so outweigh anything that you just want to be secure in that moment. And so for Prefect, we hope, of course, our customers are not coming home and their entire infrastructure has blown up. But anything that happens that goes wrong, if we can deliver information along that vector and help someone compress the time it takes to discover that, great. Like that's a real benefit. But like any insurance product, we're selected on cost. And because we're an open source product, I don't mean financial cost. I mean effort. I mean time to drop us in. And so back to what you said a moment ago, that tagline, the easiest way, that has been since day one our number one focus. If we don't try to make our product easy because we believe it should be simple or easy just for the hell of it, we focus on making it easy, because the easier it is, the more likely people are to drop it in their code when things are going right, and the more likely it is that we can deliver value when something goes wrong. And that insurance metaphor is super powerful.
So this notion that something goes wrong, let's drill down a little bit. So there's there's the notion of something going wrong, and then you have a tool that allows you to do some sort of root cause analysis, right? So kind of drill down to what's going on. But then there's also the expectation increasingly on the part of modern data teams of some notion of fault tolerance, right? So in other words, if something happens, if you're running something on a cluster, if one node goes down, it should still keep going.
Absolutely. And this is why I mentioned earlier, retries are one of the most technically difficult things that we've done, because in some ways our best opportunity to supply that is through a retry mechanism. It didn't work, we're going to try it again. It's a very brute force, but often effective way of tackling this problem. But retrying a single CLI command, which is how orchestrators in the last decade worked, is fairly straightforward. You just issue the command to wherever it was supposed to be issued. issuing in a much more dynamic environment where, let's just say you spun up a Ray cluster and it has its own caching and data locality things, and now we want to tell it to run something again, it actually creates a very interesting set of problems to solve. Who's the sort of arbiter of truth of whether the work got done here? And we need to make sure we have deep integrations with those execution clusters. Using Ray as the example here, could be Dask, could be a local machine, could be anything, right? But that scheduler, that task scheduler, if you will, running on the cluster, it may have its own belief about whether that work was done or not. We need to be able to either override it if appropriate or believe it. It may have cached that data in a place. We need to get access to that data to repopulate, rehydrate the work to be done. There's a lot of work that it takes to actually make something happen again in a world where data flow is a principal component of the work being done, let alone if we're talking about spinning up new environments and setting environment variables and getting, sensitive information there. So this idea of fault tolerance is really important to us, but if we step back from that, so like we can talk about retries, we can talk about integrating the execution layer. Our experience is that this problem is a lot simpler than people think it is. And by simpler, I mean dumber, honestly. I mean, in a way that none of us want to admit we deal with. I recently spoke to someone who was on a team that was blocked for multiple days because of an unpaid bill to a vendor, okay? And the systems just weren't working. And just because of the separation of concerns and who actually got that information, there's just no resolution. There was no, it didn't occur to anyone, or I don't know the exact circumstances, but somehow it didn't occur to anyone to raise the problem they were observing to a person who could actually fix it. And that's an example of something going completely wrong, completely separate from any data infrastructure or modern data, anything. That's just a hiccup in the stack. This person was sharing this with me jokingly. We were having a conversation like this one, talking about this problem. At Prefect, we call this problem a negative engineering problem because of, well, a variety of reasons, including how unpleasant it is. And he volunteered this example to me almost jokingly. And I was like, yeah, but that's exactly it. It was a team of 5 people on the team, 3 days lost, 15 person days were lost because of this bill. That's an extraordinary dead weight loss. And all it would have taken was getting the right email notification to the right place. Now, I'm not claiming to you that that's typical occurrence by any means. This person probably wouldn't even want me sharing if this happened, right? So this is a very atypical thing. But what I'm trying to exhibit is when something goes wrong, it's not about the sophistication of it. It's not about the fault tolerance. A lot of the times when things destroy productivity, it's just because they were unexpected and it's not clear how to even learn that they happened. And so one of the biggest things that we hear from Prefect customers when we do case studies with them is we hear this phrase, because of Prefect, I don't worry about, or I have confidence that. It's the fact that they just know that they're going to find out when something goes wrong. That can be by far the biggest value add, because instead of 5 people spending 3 days on something, one person spends 5 minutes on it. And all that time is productivity gains that can be spent working with, for example, the administrator of a Ray cluster to make sure that it's got the HA capability that it needs. And so that redirection is critical.
So as you're talking, I'm reminded of the early days of orchestration tools I would say early days, meaning 6 years ago, maybe 5 years ago.
Sure.
Where, and correct me if I'm wrong, maybe I'm misremembering, but I remember you could write, maybe quote unquote stupid Python code, and then the orchestrator would just get so confused and break. So yeah. Is that a wrong recollection on my part? But some of these early tools seem like you could make it fail with some Python code.
Yeah, I think as the author of probably a lot of the systems that enable the behavior you just described, I should be careful what I say. When I introduced Prefect, I gave a talk to motivate why we wanted to build a new system, a new way of building a system. And I'm forgetting what my talk was called, but it was basically about how frequently people hack their orchestrator and write code that goes around the orchestration primitives, because the orchestrator's vocabulary is insufficient for describing the work you want to do. And so you end up with this bottleneck where if your orchestrator, for example, doesn't know about moving data from task A to task B, then you cannot orchestrate tasks that pass data from one task to another. And that seems like a silly thing to say. Of course you can. I tell task A to run, I tell task B to run. But if that data represents a critical part of the data flow you're trying to automate, and your orchestrator has no way to even tell you about it, then sure, you can tell A to run, you can tell B to run in sequence. But in the failure case where it's something about that data quality check, availability, checkpointing, something that failed, your orchestrator has no way to tell you. And so we introduced this like incredible variety of hacks, some of which I, in a previous life, helped make canonical because they were so useful. I don't want to suggest that hacks are necessarily bad. They are often very useful. It's just that they escape the orchestrator's vocabulary, its ability to describe what you're doing, and therefore robs it of its utility. Because as soon as work happens away from the orchestrator, you sort of don't trust it anymore, right? It's like, how good can it be? It's like if I bought insurance on my house, but it excluded the east half of my house just for the hell of it. If that's the part that's on fire, what good is the insurance, right? I need a holistic solution. So yes, I think what you're describing is a little tongue in cheek from the truth, but I think it's a very real description of a situation people often found themselves in, where they're like, I want to do X. The orchestrator can do Y, which is kind of like X. So I'll write Python code. And the beauty of Python is, of course, at the end of the day, you can make it do whatever you want, and I'll make this thing happen. And 99% of the time, everything's great. And then that one time when it fails, you viscerally discover why it was that working around the orchestrator can put you in a worse situation.
By the way, another thing on failure. So you talk about the expectation of teams is that the orchestration would, try to make sure that things work. But inevitably, sometimes things won't work. Yeah. So what do you folks provide in terms of helping me diagnose when things actually are not working?
So the funny thing is that it turns out, further to what I said before about the number of hours that are lost just trying to learn if a narrative plays, one of the best things that we can do is just tell you something went wrong. And I know that sounds crazy. I know it sounds like there should be better ways to learn that, namely any of the tools in your stack. Surely they can tell you that something went wrong. I think there's a degree of fatigue there, and there's a degree of the discovery of a problem is often only because you go looking for a side effect that you know should have happened. You don't find it, and now you're working backwards through your stack. Because often when something goes wrong, what does it actually mean for it to have gone wrong? Sometimes that's not obvious to the tools you're working with. Sometimes it is. Sometimes it's catastrophic, the data doesn't arrive or whatever. We used to deal with a situation that actually deeply influenced how we thought about Prefect. Prefect's design, which was very, very, very common maybe a few years ago, where you'd be running something, well, it probably still is, you'd be running something in Spark, you'd be running a Spark application. It would fail for some reason, and it would crash in a way that took down, at the time, Airflow or whatever your orchestrator of choice was to operate it. And so you would stop running your pipeline, the crash would basically propagate into your pipeline, and you would leave this Spark cluster running, or whatever infrastructure you had. And that's obviously very, very bad, right? If you didn't expect to leave that running, and you have no way of finding out because the crash that took down your application also took down the orchestrator that was supposed to tear down the infrastructure. So who's supposed to tell you that there was a problem? You could log in and look for the absence of a success in your orchestrator, and that would be about as close as you could get, or you could try to dig into the logs in your sort of Spark infrastructure. So as we were designing Prefect, which has a very different architecture, we sort of insulated from the errors more. We asked ourselves, okay, so let's say someone runs this thing, they submit the remote application, it fails, Prefect detects that failure and properly spins down the cluster. Do we tell the user that the workflow failed, or do we tell the user that the workflow succeeded? Because the business logic was carried out successfully. A failure was intercepted, and we shut down the infrastructure, we're good. And ultimately what we decided, and this goes again way, way, way back to the beginning of Prefect, but ultimately what we decided is, we don't think we can actually make that call. There may be users in the world for whom that failure to run the Spark application in this example was a critical failure. And while, yes, we successfully contained it by tearing down the infrastructure, they want to know about that failure. And then we have this other class of users. We tend to characterize them as like our more data sciencey or our machine learning users, they're much more experimental in what they do. They may not care that it failed. They may expect it to fail, 30% of the time. And so they actually would view this as a successful run of the workflow. They don't need the failure information in their face. And so one of the primary things that we actually did before we even get to your specific question about what do we deliver is how do we give people the tools to apply meaning to what happened in their infrastructure and work with the concept of failure as a first class thing. Because if you can react to failure in code as a first class thing, that is a mind-blowing experience, because now you want to send a notification only on a very specific set of conditions. You don't have to wait for us as a team to decide that that's a universally important thing. You can do it. And we have a mechanism where people do, in fact, send themselves a Slack message under only very, very specific set of circumstances that they expect. So that's the number one thing, is actually giving people the tools, the developer experience, if you will, to treat failure as a first-class object in code. I know it's a minor, it sounds a little bit minor, but it's not something we can really talk about otherwise. Failure is failure. It's the absence of running code. Then once we get into our UI or application, it becomes about calling your attention to this. And as I mentioned earlier, it's not always as easy as saying, hey, red light went off, you should pay attention to it. Half the time, we're actually looking for the absence of an expected success rather than looking for an actual sort of materialization of failure. And that is why the expertise that we've developed as a team has a lot more to do with thinking about an insurance value prop than just what we call the fancy crown feature set, because anybody can write a scheduler. Thinking about how to detect the absence of failure is a really, really, really hard problem that fortunately my team really enjoys spending time on. But most people not only don't want to spend time on, do not care about, right? They just want that green light. They want to get this analytic in the world, whatever it is. And that's where we can be helpful. So that's the broad framing. And then I'm happy to go into more detail, but the specific answer to your question is just a million different ways that we present that information once we've collected.
So let me pivot slightly and let's start talking about the new version of Prefect, which is the main reason I have you on the show today. And I guess the tagline is code as workflows. Am I right?
Indeed.
So
yes.
The interpretation there is that make it as easy as possible for people to write workflows, where they don't have to do much thinking. The code that they have already expresses probably what they want to do. So just help them basically take it to the next step.
That's exactly it. It goes back to how do we make this easier? And so there's two ways that we can look at this decision to embrace what is basically a fully dynamic workflow engine with no need to predefine a DAG whatsoever. It's basically like a JIT orchestration engine. It just in time discovery of whatever needs to be orchestrated. There's two ways we can talk about this problem. One is from a very technical point of view, because this enables use cases that a precompiled DAG can't handle in terms of dynamicism and real time and streaming and like all kinds of really interesting things. Recursion even. And then there's this just really, really, really basic value prop. And I recognize this is like the fourth or fifth time in our conversation where I've said there's a really interesting, sophisticated outcome here. And then there's the value delivery, which is core and basic and just whatever. I keep coming back to that because at the end of the day, we've learned that that's the most important thing we can do is just help people go on with their day, right? And just give them those hours back. And so we spend an awful lot of time thinking about it.
Jeremiah, also, I think it's important for people to hear that, building a company is about providing value, not impressing people, right?
Yeah, I hopefully both. But in all honesty, at the end of the day, we know why people not only use Prefect, we know why people pay for Prefect. And at the end of the day, it's not because our scheduler is better at scheduling, it's because the value prop we deliver is real and is this insurance sort of layer. Anyway, so when you focus on making something easy to use, we focus on the less you have to change the code you would have written anyway, by definition, the easier it is to use an orchestrator. And so even in Prefect 1, which we really strove to make easy, you still had to tell us about every function you were going to run. If you wanted to let's say it's some function that spat out a string of 10 characters and you want to take the last 5, that little string manipulation, it looks like you could do it in Python, but you can't. You need to put it in a proper task. You need to put it in a DAG structure. You need to inform the orchestrator that you're going to do this. Prefect 2 says, no, you don't. Just run your code. The more that you do tell the orchestrator, the more opportunities we have to help you. But if you don't want our help at a certain point, no big deal. That's fine. If it crashes at that point, to be clear, we will not be able to help. We will not be in a position to give the insurance-like value, but you are not forced to partake of that. And that's this opportunity to have very, very incremental adoption of our features is probably the best value prop of Prefect 2, even though it almost sounds like we wouldn't make a headline out of it, because by definition, it's not a headline feature. It's actually only partially using our product. But we have people, I think we just did a live stream of it, as a matter of fact. Maybe we can link to it somehow. But you can use cron as your scheduler if you love cron, and use Prefect only to observe the status of the scripts that cron is running. And that's a one-line import with Prefect. Just tell us what function you want us to keep an eye on, and then use cron to schedule it. And the idea that you could use a different scheduler with our orchestration platform should be, at least anyone who cares about this, very surprising that we would even make this possible.
Yeah.
You can reverse it also. You can use Prefect's scheduler to run a function, which then engages some completely different observability mechanism, if you so choose. If you just love our scheduler, but you don't like something else.
So there's modularity to it, but then also there's a philosophy around that's centered around developer productivity.
And productivity is measured 2 ways. Less time spent doing things that don't matter, more, and well, they're the same, I guess, now that I'm saying them out loud, but we can make it easier to drop in the orchestration primitives that can save you time later. And in doing so, we let you spend more time on the things you're actually good at and care about, which are your job, the code that you're writing, the analytic you're trying to put into the world, the pipeline you're trying to build. And then what we hope is that through this incremental adoption, people discover the other things that Prefect can do for them. So there's a huge list of things that Prefect can do, many of which seem a little bit simple, but when you put them all together, you get a very powerful package. And so if we give people, instead of expecting people to start from, go from 0 to 60 overnight, just because you have to deploy the entire Prefect platform, no, start with a single import. In the background, we're spinning up a SQLite database. We're keeping track of stuff. Don't worry. When you're ready for the UI is there. When you're ready for the API is there. When you're ready to deploy it, we're ready too. And this sort of incremental adoption has become a really, really cool design constraint for our team, which it turns out when we embrace it is really freeing for our users. So that's on the like, how do we get people to
let me ask you this. So when you, because I like what you're describing there, but how did you arrive at it? Did you talk to users? Or?
Well, absolutely. I think, I mean, look, talking to users is kind of all we do. it's we wouldn't know what we're doing without our users, especially because, as you know.
So there's a big subset of people who ask you, hey, we want this to be more modular, pick and choose.
No, this is the interesting thing. I think because of the nature of this problem, almost nobody actually says that they want exactly this feature in this way.
Yeah, because it's somewhat surprising, right? Somewhat surprising.
Yeah, no, nobody would say this. Nobody would say this. I think that any great product team knows that what you hear from people is the outcomes that they want, usually through the lens of a feature they think would deliver it. But that feature is almost certainly not universal. It probably incorporates some unique aspect of whatever that person is trying to do. And one of the skills, I think, if I can pat my team on the back for a second, I think one of the skills my team has developed is we have this huge community. We are constantly hearing from them, what they like, what they don't like, what they're struggling with, what's hard, what they can't figure out. Our challenge is to take all that information and build a process for distilling it to actual universal statements. I mentioned orchestration primitives before. So if 17 people are asking for 17 different things, is it actually possible that they're all asking for one feature, which if only we had that light bulb moment, we could actually figure out and deliver? And so it takes a long time. We started collecting the user conversations that culminated in Prefect 2, started almost 2.5 years ago. Ironically, we called it Prefect 1 then, because that was the code name, because it was supposed to be this like all-encompassing, like we're going to handle every use case API. I won't refer to Prefect 1 anymore because it's too confusing with the actual version numbers. That was just an internal code name. After about a year of that, literally 1 year of conversations, we actually put pen to paper and started figuring out technically what was it that we were talking about doing and why was it so different. And the thing that we kept coming back to was this. As long as we had to precompile a DAG object, which is sort of just how orchestration is done and always has been done, as long as we had to do that, it meant that any use case we wanted to support and any user behavior we wanted to support, we had to write a function for it. We had to write a computational equivalent for it into our DAG, because if the DAG represents all the computation that will be done so the orchestrator can keep track of it, then it has to reflect literally anything people wanted to do. Streaming, batch, dynamic mapping, fan in, fan out, whatever, looping, whatever people wanted to do, either we had a primitive that supported it or it couldn't be done. And so as we started to like chip away at that notion, can we get away from precompiling this DAG? That's when we started getting these light bulb moments and we realized, well, wait a second. What do people actually want us to do? They actually want us just to, at the end of the day, again, in a simple sense, just tell them if a function didn't run. That's like a core value. Just tell us this function didn't run. Why do we need a DAG for that? Why is it so important for our orchestrator to know in advance how your functions all relate? And then we took a good look at Prefect 1, and now I'm actually referring to Prefect 1.0, which is a product that you can use today if you choose. And we noticed that in not a single place, actually that's not true, there's one place, in almost nowhere in that product do we take advantage of the fact that we require users to put a DAG into the backend, into the database. And as soon as we realized that, it was like, you know, the house of cards came tumbling down, and we realized the DAG is, I don't even know why we make users put the DAG in anymore. I think it feels convenient as developers to get this complete data structure and be able to make, you know, claims about it. But when we look at our product and we realize we actually don't use this information and we still provide all of the sort of utility people expect, it's like, well, why are we doing this? Why are we making our users deal with putting this DAG together? Just let them write their code. Let's figure out a way to observe what they're doing. And that's where this idea for the JIT kind of orchestration engine came from. So I just tried to summarize like 2 years of conversations into 3 sentences, but that idea of identifying what is it that people are trying to do? What is it that we're making them do that's preventing it? And then this insight that if we just sort of move to a dynamic world, it all just sort of melts away. That was the genesis of this. It was really exciting.
So let me throw out a trend that I've been observing the last few years, and feel free to disagree. But I think there's a lot of desire for engineering teams, data engineering teams, and just data teams in general, to have tools that will allow them to inject the same sort of software engineering rigor that they're used to in the way they build pipelines. And pipelines, as we've been talking to, are challenging for many reasons, but for one thing, you know, they could be comprised of multiple stages, and this multiple stages could be talking to several different distributed systems. So imagine people trying to test, unit test, deploy, manage. You know, I mean, data engineers, a lot of them come from software engineering backgrounds, so they want kind of similar kind of rigor in the way they build pipelines. So first of all, am I imagining something? Is this something that people?
No, I think.
And then secondly, I think we're starting to see positive signs.
Yes, so a couple of things. First of all, I completely agree with you, but I think there's a twist, which is that you are correct. More and more data engineers are coming from software engineering backgrounds, but data scientists, almost to a fault, often do not. And you get this very, very, very interesting conflict, if you will, therefore. you know,
Jeremiah, throw in the analysts, because now you also are starting to see low code and no code.
oh, Ben, I'm so sorry to interrupt you. I just lost your audio, got very, very, very quiet. I can still hear you very, very faintly.
Can you hear me?
I can hear you very quietly.
Yeah.
Oh, now you're back.
Can you hear me?
Yeah, now I hear you.
So then there's the third group, the analysts, because now we're starting to see low code and no code tools for data integration.
Yeah, and I am very, very, very focused on this third group right now, because more than half, about half, I think, of our largest enterprise customers right now are comprised of this analyst persona.
By the way, just to jump in here, I just did a post where I looked at data integration job postings. The top two roles are data engineer and analyst.
That aligns with what I'm seeing in the market. That's super, super interesting.
Yeah.
Why is this person here? So I skimmed over your question a moment ago. Definitely, yes.
The software engineering rigor for pipelines, right?
Definitely there. You have to do it in a very special way, because the data science persona is someone who's just like, I just want to run stuff, right? That's why notebooks are so popular. Notebooks. Okay, this is maybe a controversial opinion. I think notebooks in general are a disastrous way to, like, they're out of order. It's not clear what's going on.
I haven't used. I'm a VS Code guy.
Yeah, exactly. But data scientists love notebooks. I love notebooks at the end of the day, because they just get stuff done. I'm a huge fan of companies like Hex that are actually solving that problem, making notebooks like usable again, right? But why did notebooks rise? Because data scientists don't have time to write code. They have time to get like output into the world. And so I think the unique challenge of trying to build a data science or data stack oriented orchestrator for us is, yes, we need to embrace best practices. And I know you had my CTO, Chris White, on this podcast 9 months ago or something like that. And I remember him talking with you then, or at least I remember listening to it, all about the focus on testing and how you test Prefect workflows and test pipelines. And the funny thing is, I remember talking with him after, and he said, it's surprising because we've never really thought about that as a thing we have to add to the framework. We just took it for granted from the beginning. Especially in Prefect 2, a pipeline's a function. You want to test it, call it, see what comes out, make asserts on it, right? It sort of just all works. But it's so different than the world that used to be, where orchestration was this very much sort of arm's length at a distance. We have no idea what's going on with you or your pipeline, and good luck if you want to test it. So I think A, it is more important. B, I think tooling is accounting for that. We're writing tools that we want to use, that we wish we could use in this way. And then C, there's this wrinkle, which is you have to also respect a persona, a data science persona, which is deeply technical and has nothing to do with this. Odd thing to say, but true. And then you're totally right. The analyst persona is a fascinating one. This is someone who doesn't write code. And if we put code in front of them, they're going to walk away. But they depend so strongly on what the impact of that code is, what the side effects.
And also their impact and responsibilities are increasing. Right,
their impact's increasing
because maybe some of the reports that they're writing are just as important as anything else, right?
At the end of the day, just as our impact is through helping people gain time back, the impact of our users into their businesses and wherever that business impact is felt, and the analyst is certainly right there trying to deliver insight out of the data.
And by the way, Jeremiah, I also looked at. I have access to all of LinkedIn profiles. And I looked at the relative size of these communities. I mean, the analyst community just dwarfs data scientists and data engineers.
It does. And I think it speaks to sort of this beautiful fan out of the data world. And you and I talked about this once before, where increasingly the data stack is focused on the warehouse or the lakehouse, as it were, right? The central storage. And then you have the applications above it, some of which are becoming more canonical than others. And then you have like all of this explosion of like insight and analytical work. And that, it's like a peacock's tail. It just is gorgeous in how it explodes like that. And all of that's exciting to us because every single link between every single one of those applications is an opportunity for an orchestrator to deliver value, because it's one more place that something could get lost. But more than that, I think it speaks to why the relative size that you just described exists, the opportunities to do differentiated work are manifest as you move away from the increasingly commoditized and consolidated parts of the stack. Because ultimately, where businesses differentiate their use of the stack is how that data gets from the central repository out to, you know, an exclamation point over somebody's head because they saw something in the properly formatted chart somewhere in the world. And so
I think actually analysts have long been tasked, a subset of analysts have long been tasked to do data integration, but somehow we as a community have been overly focused on data engineers and data scientists.
Well, I think that the same phenomenon that I just described means that most of the time it's actually a lot more lucrative, frankly, for businesses to focus earlier in that stack, where while today we could make an argument that it is or is approaching a commodity status, that hasn't really been true until very recently. And so if you want to have the biggest impact as a vendor in the data stack, you probably do want to focus as early as you can, because it means any feature you deliver probably impacts as many people as possible. So I think that's true.
Without revealing future plans, how does an orchestrator play in the analyst world?
So, well, let's reveal some future plans. Why not? Let's have some fun. You're kind enough to have me on. We might as well have something to talk about. Well, there's a couple ways. Before we get to like future plans, there's a couple ways. First of all, is how do we see the world? So I just described this fan out to you, and I explained why a lot of businesses would prefer to play at the core where it's more consolidated. The way we look at the world, that's actually not true. So we look at the world as basically boxes and arrows. If I asked you, Ben, what's in your stack? How does your infrastructure work? 9 times out of 10, you're going to go to a whiteboard, you're going to have boxes, and you're going to draw arrows. And my guess is that most people we ask have a very similar set of boxes, but the arrows they draw between them are going to be wildly different. And it's really those arrows, which is to say the dependencies between the boxes, that makes the stack interesting for that business, how they take advantage of all these different logos. As an orchestrator, we only care about arrows. In an honest sense, we don't care what's in the box. You're using,
exactly.
Tool X, great. What do you want to happen after that? Tool Y, great. We'll connect them. That's the primitive that we deliver as an orchestrator. And so actually, as we move into the further reaches of that fan out, where there's a lot more arrows and a lot more boxes, it gets a lot more exciting for us, and we don't have to do a whole lot of extra work. And some of the boxes are low code, no code. Yeah, and some of the boxes may be low code, and all they need from an orchestrator is to be told when to run, or after they've run, to kick off something else that there's not, proper native integration for, or maybe there is an integration, but in the middle you want to run Great Expectations or Monte Carlo or any data quality service to make an assertion. Great. Our job is to give you arrows. You connect everything however you want. You build your data stack. You're good to go. But implicit in all of that is a big assumption, right? I said we don't really care what's in the boxes. The truth is, of course, we care what's in the boxes, because the more we know what tools you're using, the better experience we can deliver. If we want to talk about future plans, what we're looking at later this year is how do we actually help someone set up that stack? You don't need to write code to tell us that you're using dbt or Databricks or any scale,
or if your data management of choice is Airtable.
Exactly. It could be Airtable. Maybe your code's in GitHub. Maybe wherever it is. There's this sort of beautiful mosaic of vendors and tools, commercial, open source, and your stack comprises all of them as boxes. And we really, really, really want to be good at delivering the arrows, but the arrows are no good without the boxes that they connect. So one of the steps that we're going to take is make it much, 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 much easier to start introducing those boxes to Prefect sort of map of your world. Tell us, where is your code? Is it in GitHub? Are you using S3? Are you using GCS? Are you using Azure Blob Storage? Are you using Databricks? Are you using Airtable?
So does this mean, so are you saying basically expand the number of things you can integrate with?
I'm actually saying something slightly different, which that would be a great feature for the orchestrator. And of course, that's part of what I'm saying is if we know about these things, we will deliver better integrations with them and make it easier for you to manipulate them from code. I'm actually going to step further than that. This is now a product level thing, because if we can invite someone the moment they start using a Prefect product to begin inputting their stack, and then we can start going to work on their behalf, the persona who can now use our product can be that non-technical person. Now, at the end of the day, our product is a technical product, and it's going to have a technical consumer somewhere in an organization. But today, the user experience of Prefect is, welcome to Prefect. Go write some code, go throw open VS Code, go write some code. And once you run that code, there's going to be lots of interesting things for you to look at here. I find that deeply unsatisfying. I want to launch Prefect, and I want to have something that I can start doing now. And the one thing that I want right now more than anything, and I think Prefect is in the correct place in the stack to provide it, is I want a map of my data stack. I want to see those boxes and I want to see those arrows. There's nowhere that I'm aware of right now where I actually go see them all and see their activity and see what's going on. And that is something that we're hard at work on, is delivering. And we're doing it primarily for this analyst user with a huge number of knock-on effects for our technical user as well.
So let me close with one trend. I don't know if this is something you folks are thinking about: multimodality. So especially in machine learning, a lot of the things we talk about, listeners may presume it's all structured, maybe semi-structured data, maybe some text, but increasingly, you have machine learning models that in the future may rely on multimodal data, right? So computer vision with some text, computer vision with some structured data, and so on and so forth. So how is the orchestration space coping with, let's say, unstructured data in general?
So I actually think that this is one of the places where a well-designed orchestrator shouldn't need to have an opinion. So what you're describing happens to be a huge part of my background. So it's intimately familiar to me. I used to do time series analytics, but on a mix of like spatialized and non-spatial time series. And the idea, for example, of having n columns corresponding to n features was like, what a luxury I've never had. It was always this, like unstructured doesn't even begin to capture it. I think to a lot of people, unstructured means different keys and values. What we're talking about is we're talking about at a very low level, right? Just like groups of numbers that bear some relationship to each other, if only we can discern the pattern, right? And then there might be a structured component. So when we talk about this, and this is sort of the exercise I would do if I were trying to explore a specific use case. When we talk about this, we listen to how people describe the process, and we listen to keywords like and then. So for example, if we ingest the data and then we do that, we ingest the data into tool X, and then we use tool Y to pre-process it and maybe transform it or principal components, something like that, just to get it in a nice shape. And then we feed it into a learning algorithm, which is it's a diffusion model because they're all the rage right now, and it's going to incorporate text annotations from tool Z. That's great. I now know that you've got 3 different boxes, and I know that they have a dependency to each other. And so as an orchestrator, without knowing anything about what you're doing, I don't care if you're reading it out of a beautiful SQL table. I don't care if you're taking it out of
object store, right? So
exactly. It doesn't matter where that data is coming from. I know that the orchestration primitives you want are do this and then do that and then do this last thing and then combine them. And so if I knew nothing, and if my product wasn't built assuming it was a nice, normalized SQL table, we'd be good to go. The question really that we struggle with is not how do we make sure that we build tools so that a multimodal approach works, or so that these types of data work. I know they'll work because we made no assumptions about the type of data at the beginning. The real question we have is how do we deliver tooling to someone who's got a use case that depends on this, such that they can gain confidence from using our tool that they wouldn't have otherwise, which is at the end of the day, the value prop. So for example, I know that often when you're working with multimodal training, or let's use your example, right? Or let's talk about what's the image thing that's all the rage, right? DALL-E 2, right? When you're watching something like that train converge, being able to view snapshots of its trading process along with the captions being generated and just evaluate them on a pure sort of semantic level is critically important. We're not going to build Prefect to anticipate this exact use case and output exactly that type of data, but can we build Prefect to output markdown artifacts that anyone can view in our UI? Absolutely, we can. And so again, the exercise is to say, I totally understand what types of things people are doing. Let's step back and think, what primitive features can we deliver that make very little assumptions about the data, but that still deliver a really good use case for anyone who's working with it. And so that's how we think about this. I think one of the saddest things for me, actually, is that I loved coming from the world like the one you're describing. That's my background. That's what I wrote stuff on once upon a time when I was in school. I love that stuff. I now operate in a space, right, where I very frequently watch other people use our tools to achieve these fascinating results. As I said at the beginning of this conversation, I'm very excited to be here because I get to see so many different versions of this. But I won't lie to you, I miss sometimes the excitement of working on a project, on a problem like the one you described. It's awesome.
And with that, thank you, Jeremiah. And hopefully our joint survey will be out when I air this. But if not,
That'll be exciting.
I will resurface the episode. All right.
Great. Well, Ben, thank you. I always love chatting with you. Thanks for having me on today.